I will show you something invisible today. And I got questions from Trine here, which we should answer. And those questions were, are we making any progress in the clean tech work reducing the carbon footprint? And what is happening around us when it comes to innovations, technology development, and individual efforts for a better environment? From my perspective, I will start to show you a map of clean tech development. This is an area outside Stockholm Central, Alvik, just south of it. Every single red dot represents an energy well for one house. Every house in the block has their own energy system. Here in Sweden we call it bergvärme or rock heat. Does anyone know about bergvärme or rock heat or shallow geothermal or something like that? Raise your hands. Have you heard about it? Good. It looks like it usually does in Sweden. But I don't think that 95% of you know what we can do with geoenergy, which I call it. I will try to explain for you what it is. Renewable energy, those are taking the most of their energy from a renewable system. When we talk about renewable energy, mostly you think about wind power, hydropower, solar plants, and maybe biomass. I think of this little thing, the sun, which delivers a huge amount of energy to the surface of the Earth, which is actually stored into the ground. And we can use that for our properties, for our houses, for processes, for heating and cooling. And the process is fairly simple. During the year, the temperature in the ground varies in the surface. But approximately below 15 meters depth, you have no change at all during the year. It's a constant temperature all year round. The temperature increases with increased depth, with, in Sweden, approximately 2 degrees per 100 meter. That's called the geothermal gradient. It's due to the nuclear power plant down there. Now, if you look on a temperature map of Sweden, we can see on a 100 meters depth, the temperature of the ground coincide with the annual mean temperature on that location. So here in Kristianstad, we have approximately 10 degrees as an annual temperature here outside this building. And 100 meters depth, it's the same. You can see up in the high north, somewhere there, 3, 4, 5 degrees maybe. And that's a result of the solar inclination. The sun delivers more energy to the south, of course. And I'm quite sure that most of you have been sitting a late evening, maybe a summer night in the archipelago sometimes, sitting on the warm bedrock. And it's still warm from the day sun. It takes time to change temperature in the bedrock. And that together with, I just said, that we have a constant temperature over the year, makes this suitable for heating and cooling our buildings. If you look on a map, a global map, and you look at places where you have you measure the temperature gap between the warmest month and the coldest month, you can see, like in Vladivostok, we have 60 degrees differences. Here in Sweden, we have approximately 25. So if we return to Kristianstad here, if we take 200 meters depth, we have 2 degrees per 100 meters depth, we will have about 12 degrees in 200 meter. That means when we have 30 degrees in the summer, which we can have, we have 12 degrees down there. We have a perfect source for cooling. And in the winter, when we have -5 degrees and it's blowing, and it's always blowing here in southern Sweden, you have a perfect heating source, which we can, together with the heat pump, actually use to heat the building. Normally, in Sweden, we use this rock heat or bergvärme. It's a singular borehole. We have a pipe, a heat exchanger installed in the well. It's a normal plastic pipe, and you are circulating an alcohol with approximately a good grog strength, about 30%. And just circulate that. It's not connected or coming in the environmental. It's just circulating and extracting heat or coolness. But this is the heat. 200 meters depth normally. The well itself, it's about 10 centimeters in diameter, and we have approximately 450,000 of these in Sweden, which is hilarious, actually. Now, I think this is geoenergy, yes, but I think that geoenergy is most interesting when you have a demand for heating and cooling on the same time. And to use that possibility, you have to connect several boreholes together to each other. And by that, you actually use a huge volume of rock. Like this example, it's under the building, we have boreholes with a 5-6 meter spacing, and when we are in the wintertime extracting heat, the bedrock is cooled down, much colder than the surroundings. That makes it to an enhanced cooling source when it starts to be a cooling season in May. So maybe we could take it down to here in Kristianstad to 5 degrees, which is a perfect cooling source. Now, when we take out the cooling, we get something warm in return and warming up this bedrock again, this volume of bedrock. So we are actually storing heat and cooling from season to season. Those system is quite efficient. We can run them with a COP. That means that if you have a COP of 5, you're paying for 1 part and getting 5 back. 4 are for free. And that is renewable, all of it. Now, the contribution from the geoenergy in Sweden in 2014 was 15 terawatt hours. It's not bad. That's exclusive the electricity that the plants were running for. That's the same as the heating demand for 750,000 homes, or 6.5 million tons of garbage burnt, or 1.3 times the total Swedish wind power production. Okay, it's electricity. Maybe you shouldn't compare them, but I think you could have something to compare with anyway. That is actually the 3rd largest renewable energy source Sweden has, 15 terawatt hours. And that is approximately 10 to 15% of all houses in Sweden are actually warmed and cooled by this. And today we use it in residential, office building, hotels, airports, churches, telecoms, and the last one, infrastructure. And that is coming, and I will talk about a little about that. A nearby example is this building. This is Lund. This is the chemical department, Ingvar Kamprad Design Center, and this building over here, which is the architectural house. It's large buildings, and all of these are heated and cooled by a borehole thermal energy system. It was installed in 2004, even if they have district heating and district cooling in the street just outside. The owner of the properties decided to go for this. I think it's interesting how big this system is. It takes this place in its position. It's not very much. Before they built the system, it was a parking place, it was a bicycle road, and it was lawns. After it was built, it was a parking place, it was lawns, and it was bicycle roads. The students going from their apartments to the university in the mornings, they don't have a clue. They don't see it, they don't smell it, they cannot hear it. And I think that's a problem for our business with geoenergy. People don't know about it. Maybe I'm from the drilling side. Maybe we should leave all the boreholes 1.5 meters above the ground. Then you will see that people should be aware of the existence. Now, this is the only thing you see, actually. It's not more. This is a wonderful example of a system when you actually use groundwater instead, which is much more efficient. It's Arlanda. How many have been on Arlanda? Good. It's not a sign anywhere that is actually the biggest aquifer system in the world. I think it's a pity. Nevertheless, it's a nearby esker where you actually pump up groundwater, take out the energy, and return it and store it for the coming season. You're heating and cooling the buildings, and you're actually snow melting the gates. And I think it's interesting to read this figure here. SPF, which is a seasonal performance factor, 60 on the cooling mode. You're paying for 1 part of electricity and gaining 60 back. 59 is 100% renewable. You can actually contract the last part, which is electricity, with renewable electricity if you want to. Not bad. I think it's better than the banks. The single-family houses start to be filled up with geoenergy in Sweden. A large conversion has started in the multi-family houses, but it takes time. It takes time to introduce a new system, even if this is mature technique today. But there is also political issues. Not everyone likes to use electricity for heating. But that's another question. Don't go into that because we don't have time. I said infrastructure before. And for me, infrastructure is railways, roads, and airports. This is a very interesting example from Switzerland. It's been running since 1994. It's a bridge where they had problems with ice. They grouted in a heat exchanger into the tarmac, which is a fantastic solar collector, isn't it? And connected that to a borehole system. And when it was winter and problems started to erupt, we're just running the pumps circulating groundwater, now hot groundwater, to melt away the snow. This is the rail yard from Gothenburg in 1942. This is the way they took away the snow and ice. This is the railway in Gothenburg in 2014. That's not clean tech development, I would say. I found this, finally, someone had put up a thought. This is from Hamburg, one joint where they're trying to connect a geoenergy system with a heat pump to the joint. I think it's extremely interesting, and well, the Swedish governmental company running the railway should actually look into this. They might come in on schedule next time. So I think it's a huge possibility to use this in the railway system. Airports, of course. I mean, 3,000 meters of runway, 50 meters wide, water solar collector. So we can get rid of 5 to 10 trucks trying to get rid of the ice and snow every time it starts to snow. And it does in Sweden, actually, quite often, even. There's one example from the States, one example only with this system. And what I know about, it works quite good. Hope that Swedavia and Transportstyrelsen likes this. Now, we already have energy systems, and there are some challenges to implement new ones. So how can we manage to integrate a new energy system into the society? You need to have three things. You need to have the needs, desire, and regulations. The needs is quite easy. I mean, we need heating and cooling. What about desire? Well, global warming and a desire to do something for the climate is absolutely a force to change into a renewable energy system. But my experience says that this is absolutely the main task. Money. Can you save money on one system instead of another? It will be the main force. And if you look on a graph on oil price and compare that with the sales of, let's say, heat pumps, they coincide very, very well. So it's not a story. What about fashion? Fashion could be clothes, it could be cars, it could be boats, but I can promise you by experience, it could be something sexy like a heat pump as well. Now, this is not only a result of money, or maybe a desire to do something for the environment. The neighbor bought a heat pump system, a geoenergy system, and that one did as well, and that one as well. Of course I have to do it as me too. This is definitely a result of fashion. What about regulations? Well, the RES directive from 2009, the EU directive, there's no doubt geoenergy is a part of the renewable energy sources, put it up in the directive. But there are actually other problems anyway. At least in Sweden, many municipalities own their own district heating system. And they are also the one who gives authorization to drill for those systems. And in some places, there are conflicts, and that's a pity. There's a legal aspect in EU that's of a free market, but apparently really not for everyone. I don't see the district heating systems as a foe. The opposite. I mean, it's a very good way to distribute energy. And there are examples of combinations of those systems. And I know that there are research going on to even increase that. It's a very interesting development. Regulations are important, and it's fundamental that politicians have knowledge about all possible systems. Integration of an energy system in a society, it's a multitask, it's a long-term work, and the objectives are many. So to succeed, the politicians must provide guides to energy policies and regulations. They must provide guides to select appropriate technologies to meet the energy demands. They need to provide guides to invest in energy infrastructure, and I think most important, they need to produce guides to increase research in technology which has low environmental impact and good economical benefits for the users. And the last one, I think, is most interesting and most important. That said, I think we could state that energy sector is a main player in a society's economy. Heating and cooling are everywhere, even in the infrastructure. I'm finished just a second. And it's regulated by authorities and politicians. Now, Trine, the questions. Are we making any progress in the clean tech work reducing the carbon footprint? Yes, ma'am, we are. And in a global situation, Sweden is a front player to reduce the carbon footprint. And geoenergy is absolutely one reason. Now, what is happening around us? It happens a lot, but we don't hear it, we don't see it. And maybe it's too slow as well. Sweden is the most dense geoenergy country in the world. We should use that possibility more to look in the potential instead of raising walls. We should also promote and export this technology to other countries. I will finish my presentation with a map from the European Geothermal Energy Council. It shows the enthalpy of the ground. You see the high red areas in Turkey and Italy and Iceland. That's geothermal. It's hot. It's of non-interest. We don't have that in Sweden, or at least. Sorry. Going back. The light color, everywhere, shallow geothermal. So, the sun is shining everywhere. The energy is everywhere for everyone to use. And there is no geological or neither geographical barriers to use it. So thank you for the presentation and the possibility to be here.
Yes, thank you, Johan. And thank you for thinking of the questions and really taking it to heart. We appreciate that, and I think it was very clear.
You want to have the questions afterwards?
Now I'd like to see if there are any comments from your colleagues here. You can hold it, it doesn't bite. but any thoughts? You're in the industry as well. Any reflections on what Johan said?
Solar clear.
We're all clear?
We're all clear.
All clear. Good.
Yes.
Well, there was one geothermal project outside Lund, which was terminated.
That's correct. When you say, there's one geothermal project running since 1983, I think, in Lund, which is, you call it deep, it's not really deep geothermal, it's 800 meters. They're taking up temperatures about 25 degrees. There was a trial to drill to 3.5 kilometers. But the situation for deep geothermal really isn't really good in Sweden. It's about the thickness of the crust to do. And we don't have the same situation that they have in Iceland, and it's not so. And we could be glad for that in many ways as well. I mean, it's not so many earthquakes in Sweden.